Hi viewers, in this video we are going to discuss about implementation of tree address code in compiler design. Myself Shankar, and let's go to the video. The tree address code can implement in three ways. One is quadruples, triples, and the last one is indirect triples. These are the three forms we can use to implement the tree address code. Let's see one by one how we are implementing. The first one is quadruple. Quadruple has four fields called operator, that is op, argument 1, argument 2, and results. The op field, that is operator field, contains an internal code for the operator. We just consider the three address instructions that x equal to y plus z. So it represented by placing the plus in operator and y in argument 1 and z in argument 2 and x in results in the form of quadruples. And there are some few exceptions are there. The first one is instructions with unary operators like x equal to minus y, unary minus y, or x equal to y, that is for copy or assignment operation, and this is for performing unary minus operations. So in this category, we will not use argument 2. We are keeping it as empty in the quadruple form. In the quadruple form, what we discussed is it consists of operator, argument 1, argument 2, and results. So in this case, unary operator case, we will not use this argument 2. So you have to note that for copy statements like x equal to y, in this case, the equal to can consider as op, that is operator for assignment operations. And operators like param use neither argument 2 nor results. The conditional and unconditional jumps put the target labels in the results. So let's see one example. The expression a equal to b star minus c plus b star minus c. So for this expression, you have to generate the three address code, and you have to implement this three address code in the quadruples forms. So let's see first how we are generating three address code for the given expressions. So here a is taken the entire expression result, and this entire expression result is assigned to a. So first we need to evaluate this expression, right? So here we will consider the two sub expressions, that is b star minus c, this is b star minus c for the comment. So it two should get summing up, and then the result is goes to a, right? So here first what we have to do, we will consider the left hand side expressions. So here first we need to calculate the minus negation of c, right? So minus c is assigned to temporary variable 1. Then what we have to do, we have to multiply with b. So that is for second instruction, that t1 is minus c. So b star minus c assigned to t2. So similarly for t3, minus c t3, and t3 is multiplied with b, which is assigned to t4. So this sub expression is over, this sub expression is over. So finally what we have to do, we have to summing up of these two, and then the result is stored to a. So summing up of t2 and t4 will get t2 is b star minus c, t4 is t star b star minus c. So t2 plus t1, and the result is stored in t5. Finally the result of t5 is assigned to a, right? And let's see how we are implementing this three address code with the quadruple form, right? Already I told you that the quadruple form has four fields. One is operator, and another one is argument, the next one is argument 2, and the last one is results. So consider the first three address code instruction, that is t1 equal to minus c. Already I told you that in this case unary operator we will not consider argument 2, just remember this, right? So here the operator is minus and the argument 1 is c, right? So we will not use argument 2 for this unary operations, and the result is stored in t1. So t1. The next instruction is t2 equal to b star t1. So here the operator is plus, so sorry, multiplication. So multiplication is operator, and the argument 1 is b, and the argument 2 is t1, and the result is stored in t2. Similarly, the next instruction t3 equal to minus c. So here the operator is minus, argument 1 is c. We don't use argument 2 for unary minus operations, and the result is stored in t3. So in the next t4 equal to b star t3. So here the operator is multiplication, argument 1 is b, and t3 is argument 2, and the result is t4. And next instruction t5 equal to t2 plus t4. So here the operator is plus, and argument 1 is T2, argument 2 is T4, and we are storing the result it into T5. So the next one is assignment operations. Already I told you that in the assignment operation on alone, we are considering the equal to as operator. So here the operator is equal to, and the argument 1 is T5, and we are storing the result into A. And here also we are not using any argument 2. So such a way that we are implementing a 3-address code in the quadruples forms. And the next one is triple form. In the triple form has only 3 fields. The fields are called as operator, argument, and argument 2. So what we have observed here is we will not use any result field, right? So in the triple form, we have used only operator, argument 1, and argument 2. So using triples, we refer to the results of an operation, that is X operator Y, by its position. Instead of result operand, we are referring the results with its position rather than explicit of temporary name. Thus, instead of temporary name T1, a triple representation would refer to the position of 0. We'll see later. And parenthesized number represents the pointer into the triple structure itself. And in position or pointers to positions, we are called value numbers. So instead of generating 3-address code, so in this example, we have generated 3-address code for the given expressions. Instead of 3-address code, we have generated here syntax, right? So you just listen how we have evaluated the expression as B star minus C, B star minus C, and then we are getting summing up, then the result is stored to A, right? So this is for B star minus C, right? And again, we are generating the syntax B for B star minus C, and then we are summing up these both, right? And finally, we are copying this result into A, right? This is what we are generating the syntax tree for the given expressions. So, okay, however, we are generating the same 3-address code to triple form, right? Implementing the 3-address code into triplets form, right? The same 3-address code. So initially what we did, unary minus, right? Minus C. So minus is operator. We know that the argument 1 is C. We will not use the argument 2, right? And next what we did is, so instead the 3-address code what we have written is T1, T2 equal to T1, B star T1. That's what we have written as a 3-address code. But here we are not using this temporary variable. So only B star T1 we have to use. So, but also this T1 also we will not use, right? So in triplest form, right? That I said here, right? You just listen here. Instead, explicit temporary name we will not use. Instead that we are using by its position, right? So here initially what we have 0 is minus C. So we have to multiply that minus C with B, right? So multiply is an operator and argument 1 is B. For this minus C, we have not used any temporary variable. Instead of temporary variable, we are using its position as parenthesized number, right? So similarly, for the next sub-expression, we have used minus C, argument 2 is not there. Right? For the next, what we have to do, we have to multiply the B with minus C, right? Star is operator, B already we have in argument 1. Instead of temporary, we are referencing the number as 2. That is parenthesized number by its position. And next what we have to do, we have to summing up of these two sub-expression. First sub-expression is appears in the position of 1 and second sub-expression is appears in the position of 3. These both should get summing up, right? So plus is an operator. First argument will be placed in the first position. Second argument will be placed in the third position. And finally, what we have to do, the result will be stored in the fourth position. So finally, this entire expression result we have to store in A, right? So here equal to is an operator. A is argument 1. From the fourth position, the results, we are storing it into A. So such a way that we are implementing triplest form from the 3-address code. And next one is indirect triples. Indirect triples consist of listing of pointers to triples rather than listing of triples themselves. For example, let us use an array instruction to list pointers to triples in the desired order. With indirect triples, an optimizing compiler can move instructions by reordering the instruction list without affecting the triples themselves. We consider the same example, right? Instead that we are using the pointers. The zeroth position will get minus C operation. The first position pointer will get B star minus C, right? These are already we have explained in the recently. And second pointer will get again the sub expression called second minus B minus C, second sub expression minus C. And the third pointer will get B star minus C, second sub expression. The fourth will get summing up of two sub expressions. And finally, the fifth pointer will get store the results of this expression into A. The next one is static single assignment form. It is an intermediate representation that facilitates certain code optimization. Two distinctive aspects distinguish the SSA, that is static single assignment form, from the three address code. First is all assignments in SSA are to variables with distinct names. Hence, the term is static single assignments. Note that the subscripts distinguish each definition of variables P and Q in the following example. I'll tell you later. In this static single assignment form representation, we just consider the example. If the expression is like this, E minus A plus B minus C star D, this is one sub expression. The another sub expression is A minus B minus C. So this can be written in the form of three address code as well as static single assignment form. Let's know the difference. So here initially P have the inner sub expression, that is A plus B. And next this A plus B get subtracted with C, that is Q equal to P minus C. And next again P equal to Q star D. Q means we have already A plus B minus C, that we are getting multiplied with D, right? And next what we have to do, we have to again subtract with E, right? So that E minus P, this P contains A plus B minus C star D. And next what we have to do, this sub expression should get summing up with A plus B minus C, A plus B minus C already with this Q, right? So P, this P contains E minus A plus B minus C star D, and this Q contains A plus B minus C. So A total sub expression will get now. Right. So here the problem is, while explaining itself, we are creating confusions that which Q reference which sub expression, which P reference which sub expression, that we are getting with the temporary variable that generated by the three address code. In case of this, this can be rewrite with the static single assignment form. Each will have unique name with the subscript number, that is we have given here. Each temporary can have the subscript. If subscript can distinguish the sub expressions, then we will not have any confusions, right? So you just look at here, P1 will get A plus B. The same three address code will be generated with the static single assignment form. And next Q1 will be P1 minus C, right? So P1 minus C in the sense A plus B minus C. So this expression, sub expression is over. Next P2, another form. For every parenthesis, they are renaming, right? For P2, what they have written is Q1. Q1 means A plus B minus C star D. Next P3 means this expression, right? So this whole term will be there in the P2. So E minus P2, which means that E minus A plus B minus C. So it would be clear. So now when we are becoming here Q2 equal to, right, P3 plus Q1. P3 is what? P3 is E minus A plus B minus C star D, right? So Q1 is just A plus B minus C. So here we don't have any confusion if we are using with the static single assignment form with the subscript operator temporary variable forms. But over here we are getting confused while generating here this final expression. The compiler may get confused that this P would be from here or there, or this P what, right? So that confusion will be avoided with the static single assignment form. Thank you all for watching this lecture series. Thank you once again.